This is the homework help video for Physics Unit 3 homework number 1. I'll go ahead and do 1, 3, 5, and 7 on this homework. 1, 3, 5, and 7. The first question here talks about how every March the swallows return home to San Juan Capistrano, California after their winter in the south. In the first part they fly due north and cover 200 kilometers on the first day. So they're going due north and covering 200 kilometers. The second day, and I'll go ahead and change colors for this, they continue flying due north, but they cover 300 kilometers. And then the third day, they continue flying due north, but they cover 250 kilometers. It asks you to draw a vector diagram of their trip, which is what I just drew for you there. We're drawing the vectors, and we're putting the tail of one next to the head of the previous vector. So we've got tail and head. So we're just kind of stringing them on end. And we drew the vector diagram. We also want to find the total displacement for their 3-day journey. In this case, it's really easy. All we have to do is add those three vectors. Since they're in the same direction, we can just add them. So we're going to take 200 plus 300, which is 500, plus 250, which is 750 kilometers. And that'll be your answer for number 1. Number 3, we've got Katrina and Maria, and they are fishing in the summer, and they both decide to go for a swim. Katrina dives off the front of the boat with a force of 45 newtons, so we're going to draw a little bit of water here, and we'll draw a nice boat. Yes, this is a boat, and it's a good one. So here's your boat. Yeah, you get the picture. And we've got Katrina here, and Maria, I'll put a K for Katrina, and Maria here. And Katrina dives off the front of the boat with a force of 45 newtons. So she's pushing herself out with a force of 45 newtons, and she's pushing the boat back with a force of 45 newtons. Maria, on the other hand, jumps off the back of the boat with a force of 60 newtons. So she pushes herself forward 60 newtons, and she pushes the boat forward 60 newtons. I guess she pushes herself back would be the way to look at that. Now, pretty obviously here, these forces don't balance. 45 and 60 are not equal. So we have to draw a vector diagram. For your vector diagram, it can be as simple as a box for the boat with 60 newtons in Maria's direction and 45 newtons in Katrina's direction. Katrina pushed the boat back, Maria pushed the boat forward. The other thing that we're asked to do is find the resultant force on the boat. Now, we've got 60 in one direction, 45 in the other, so the resultant force here is just going to be 15 newtons, because 60 minus 45 is 15. So if we were to redraw this diagram with the resultant force, we'd have our boat here with a 15 Newton force pushing forward on the boat. That's number 3 for you. Number 5, we've got Zach Thornburg on a camping trip here, and the scout leader gives him a compass and a map, and the directions on Zach's map say to first go 500 meters north, so we're going to go 500 meters north, and then 200 meters east. I'll mark an X where we started here. 200 meters east. 300 meters south. And then 400 meters west. So that's roughly what that would look like. Yes, Zach is walking in a circle. If he follows the map, what is Zach's displacement? And we're supposed to solve this graphically. I don't have graph paper on here, but hopefully you have some that you can use, or you can make a graph of your own. But I think we can see what we're looking for here. We want to find his displacement, so his distance from point A to point B. A and B. Now, we know that he went 500 forward, so this was a 500. He went 200 east, 300 south, and 400 west. So his northern component here, this piece of his total displacement, is going to be 200 meters. His western component is also going to be 200 meters because he went 200 east and then 400 back west. So what we've got here, and this works out really nicely, is a right triangle. And not only that, it's a 45, 45, 90 right triangle. So we know the two legs. The way to find our hypotenuse, or our displacement in this case, is simply to use a little Pythag, 200 meters squared plus 200 meters squared equals x squared. When we solve that, take 200 squared plus 200 squared, you should get 80,000. And then when you square root that, you're going to get 282.8, because we do want 4 sig figs here, meters. Now, you also need, for displacement, an angle. But fortunately, we already know that. It's 45 degrees north of west. You could also say west of north if you wanted to. But what we're saying there is that he's 45 degrees, this is due west, he's 45 degrees north of west. And that would be your answer for number 5. And this is a nice Rock Chalk Jayhawk and Christmas problem. The last one here, I'm going to have to erase the board for this one, just so that we have some space, so I'm going to go ahead and do that right now. For the last question, we've got Hunter, and he's shoveling snow after a storm by exerting a force of 30.0 newtons on his shovel at an angle of 60 degrees to the vertical. This is absolutely a draw it out question. We've got a vertical line right here, and we've got Hunter's shovel, which probably looks something like this. Even those of you haters about my art skills will like that shovel. And he's pushing it. We've got a 60-degree angle to the vertical. So this angle right here is 60 degrees, and he's pushing it with a force of 30.0 newtons. Now, this question is probably the most difficult on this homework assignment, because we have to look at the horizontal and vertical components of the force exerted by Hunter. But if we simplify this problem a little bit, it's not nearly as difficult. So I'm going to draw a triangle here. We've got our vertical line, a horizontal line, and then we've got Hunter's shovel. We know that this is 30.0 newtons, and we know that this is 60 degrees. We don't really know too much else here except that this is a right triangle and that this is a 30, 60, 90 triangle, which is a special kind of triangle. Now, we can do some sine, cosine, tangent stuff here. I'm just going to tell you a special thing about a 30, 60, 90 triangle if you didn't know this already. This leg has to be 15.0 newtons. In a 30, 60, 90, the short leg will always be 1/2 of the hypotenuse. For this leg, we could use the trig identity here, and I think that's what we're going to go ahead and do. I think it makes the most sense in this case. So we're going to want to use sine of 60 equals x over the hypotenuse, which is 30.0 newtons. To solve this, all we have to do is multiply by 30 newtons. And when we do that, excuse me, we should get 26.0 newtons for X. Now, which one's horizontal, which one's vertical? That's fairly easy. This is our horizontal component, and this is our vertical component. Hopefully that helped you out a little bit. Hopefully you can get this homework assignment done, and I will see you soon.